In this lecture, we are going to see the IP protocol and different types of protocols. So let us begin with protocols. Now make sure that you become comfortable with protocols because protocols are very important in computer networking in order to understand how computers communicate. So the first protocol that we are going to see is the Internet Protocol. The Internet Protocol, that is IP protocol or IP, is a set of rules for routing and addressing packets of data so that can they travel across networks and arrive at the correct destination. Data traversing the internet is divided into smaller pieces called packets. IP information is attached to each packet, and this information helps routers to send packets to the right place. Every device or domain that connects to the internet is assigned an IP address, and as packets are directed to the IP address attached to them, data arrives where it is needed. IP is connectionless and unreliable protocol, meaning it ensures no guarantee of successful transmission of data. We have discussed what are connectionless and connection-oriented protocols earlier. In order to make it reliable, it must be paired with a reliable protocol such as TCP at the transport layer. Now, TCP is a connection-oriented protocol, meaning it ensures the successful delivery of data. You cannot combine IP with UDP because both the protocols are connectionless protocols. The Internet Protocol is responsible for addressing host interfaces, encapsulating data into datagrams, and routing datagrams from a source host to a destination. For these purposes, the Internet Protocol defines the format of packets and provides an addressing system. You can see this is the image of an IP header. Each datagram has two components, a header and a payload. The IP header includes source IP address, you can see here, then destination IP address, and other metadata needed to route and deliver the datagram. The payload is the data that is transported. This method of nesting the data payload in the packet with the header is called as encapsulation. Now let us see what this IP header has got for us. You can see this is a 32-bit IP address, IP header. We have seen that IP address is 32-bit. So what is version? This 4 bits define the version of the protocol used, example IPv4 or IPv6. The internet header length, that is IHL, defines the length of the entire IP header. DSCP, that is differentiated services code point, this is the type of service the IP header is going to use. ECN is explicit congestion notification, which means it carries information about the congestion seen in the route. The total length describes the length of the entire IP packet including the IP header and IP payload. IHL is used for IP header, whereas total length includes IHL value plus the length of the data. Now identification. If IP packet is fragmented during the transmission, all the fragments contain same identification number to identify original IP packet they belong to. Now what are flags? As required by the network resources, if IP packet is too large to handle, these flags tells if they can be fragmented or not. In this 3-bit flag, the MSB, that is the most significant bit, is always set to 0 because there are only 2 flags. 4 flags available, 0, 1, 2, 3 and 4. The fragment offset, which is this. This offset tells the exact position of the fragment in the original IP packet. Time to live, that is TTL. To avoid looping in the network, every packet is sent with some TTL value. Generally, the TTL value is 64. Now this TTL value tells the network how many routers this packet can cross. At each hop, its value is decremented by 1, and when the value reaches 0, the packet is discarded. So the packet can either be discarded before reaching the destination, and therefore it is not a connection-oriented protocol if IP is used alone. So, for example, the IP packet goes the TTL value for IP packet is 64 from router A. Now from router A, if the IP packet goes to router B, the TTL value gets decremented by 1 and becomes 63. This goes on until the IP packet tries to reaching the destination. Now, protocol. This protocol field tells the network layer at the destination host to which protocol this packet belongs to. That is the next level protocol. For example, protocol number of ICMP is 1, TCP is 6, that is transmission control protocol, and UDP is 17. Header checksum. This field is used to keep checksum value of entire data, which is then used to check if the packet is received or error free. The field is used to check some value of the entire header and not data. Then source address. 32-bit address of the sender of the packet and destination address is a 32-bit address of the receiver of the packet. Options. This is the optional field, it is not compulsory to field. Then the value of IHL is if the value of the IHL, that is header length, is greater than 5, then these options may contain values for options such as security, record root, timestamp, etc.